Hello, everyone, and welcome. This is Plexus International. My name is Chris Peterson, Global Marketing Manager here at Plexus. I'd like to welcome you to Improving Your FMEA Development Process with Jeremy Hazel. We'll get started in a few moments. Just wanted to get over some housekeeping items. If you do have any questions during the webinar, feel free to submit them on the bottom of your screen, I believe, through the Q&A. The chat will be reserved if you need anything from me, the moderator, directly. And happy to introduce Jeremy Hazel now to you. Jeremy, master trainer, consultant, author, speaker. You may have seen him before online or on YouTube, teaching FMEA core concept or the core tools. And we're very excited to have you today. With that, I'll hand it over to you, Jeremy.
All righty, folks. And as Chris said, welcome, welcome, welcome. You guys may have seen me before. Some of you have found us through the YouTube channel. Some of you may have taken classes with me. I will tell you straight up, for the last 3 years since this new method's inception, I've done nothing but consult, implement, and author on FMEA. And for the 20 years before that, that was a majority of my focus, was FMEA and risk-based thinking in general. So what we're going to be talking about today, I'm going to go ahead and scroll a couple slides back here. We're going to talk about improving your FMEA development process. Now, notice there are two very important words here: development and process. And what we're going to be doing, we're going to be giving you a couple things here to help improve. So let's take a look at the agenda. Now, the first thing that we're going to cover, this is a new concept for most people on this webinar. We're going to talk about the FMEA lifecycle, and we're going to share something with you that is not necessarily public knowledge. It is a model that we have created here at Plexus to explain the development of the FMEA. So the first thing we're going to do right from the jump is we're going to introduce you to how the FMEA is a process, not an event, and how this thing goes through a life cycle all its own. Once we understand the life cycle perspective, we're then going to move into the 4 stages. Now, the 4 stages, we're going to highlight them here. The 4 stages we're going to be talking about are initiation of the FMEA. Then we're going to be talking about the development phase of the FMEA. And eventually we'll be talking about the maturity phase. And lastly, we'll be talking about the phase that we call here at Plexus the leverage phase. And what we're going to do here is we're going to give you some tips in each one of these stages to help you in your FMEA development process. So that's what you could expect from us in terms of what we're going to be doing here today. I will tell you that straight up, this is not going to be death by PowerPoint. For the hour that we have, I'm going to be occasionally turning off the slide deck and talking to you directly. I'm going to be annotating on the slide deck, but realize there are limitations to the webinar format, and a majority of this is going to be a one-way valve. We will be pausing for some poll questions. Now I'm going to stop share so I can talk to you face-to-face about this. We're going to have 2 polls throughout this webinar, and the polls are extremely important. The polls allow me as a presenter to know who is out there in webinar land. So if we launch a poll, I need you folks to participate to make sure that whatever comes out of my mouth after the poll, I can frame it in a way that is valuable to you. Because not only am I standing up here for an hour sharing what I know with you, but you are dedicating an hour to get the information from me. So the polls help me figure out how to spin this information any way that we would see valuable to you. All right, so let's go ahead and keep this ball rolling. All right, so the first thing we're going to do, we are going to launch the first poll. Now, what is about to happen? We're going to come in through here, and the first thing that we're going to do is you're going to see the polls. Let's go ahead and find them here. Let me go ahead and stop my share. All right. Chris, are you with us?
Yep, I'll go ahead and launch that.
All right, good deal. They have disappeared. All right, so the polls are as follows. What is your current FMEA situation within your organization? Now, this is going to be a multiple choice. Currently, you may be using fourth. Some of you may be in transition. Some of you may be coming out the other side of transition. I need to know where the majority is in order to help you get to the right area. The second thing, which industries do you support? I will tell you that I have 5 books, as Chris mentioned, out there on the topic of different systems. I've authored on medical device, aerospace, automotive, general risk-based thinking, and also ISO. And how a medical device company treats FMEA is completely different than how an automotive company does. So this is going to help me frame what comes out of my mouth. The third poll question, how many facilitators do you have? In this new AIAG VDA method, the facilitation role is paramount. And so we need to know how many we've got. And the last question, I'm interested in the experience level of the group. It looks like quickly around half of you are 8+ years. This tells me we have a higher than average experience level, and I can talk about some more advanced topics. Now, I have a rule. The polls end when I hit 70% participation. So if you want the fun to end, participate. We are currently up to 65, so we are quickly approaching. I have no delusion that we will hit 100%. 100% is never achievable. All right. I'm going to go ahead. I'm going to end this poll. Now, I'm going to share the results with you folks. One, the reason I do this is because I want you to see that you are not alone. I want you to see who's to your left and to your right out there in webinar world. So a majority of people are either currently using the older edition of AIAG or they are transitioning. An overwhelming majority of you are in automotive and aerospace. Now, the good news is aerospace right now is a little bit split between AIAG VDA and the J1739 version of FMEA. Everything I'm going to cover today is largely agnostic to both. So the good news is there's going to be no dichotomy. All right, the third one. Most of you have between 1 or 4 facilitators. Some of our larger global people may have 5 or more. And the majority at 43% have 8+ years in FMEA. This is awesome because now I do not have to go back through what a function is, okay? So I'm gonna go ahead and stop sharing. This gives me what I need here. Close that out and let's roll. All right, so the first thing that I wanna share with you folks is the idea that the FMEA is a process, and I want to describe the FMEA life cycle. Now, historically, we used to think of FMEA as an event. So for those that are familiar with this diagram, this is the APQP flow. And the design FMEA magically popped into existence sometime during product design. And the process FMEA would magically pop into existence sometimes during process design. Now, I use this term very succinctly. We used to think of FMEA as an event, as a deliverable. That is the wrong way to do it. Because if you treat the FMEA as an event, it led to a mindset of it is a one-time thing. And this is huge because one of the problems that most organizations have is they do not keep up on the FMEA. And the reason you don't keep up on it is because you treat it like an event. You treat it like a concert. Think of it this way. When you go to a concert on that Tuesday, the 24th, it's over. The event is ended. FMEA is not an event. More so, it is a process. And much like every other process, it shifts and changed. And this mindset has historically been how we thought about it. What we offer here is a new way to look at FMEA, which will not only help your organization, but help you explain it to folks. If FMEA is an event, it goes through the same stages as a human creature. When an FMEA starts its journey, it goes through what is called the initiation phase. Now, initiation happens over here. Think of it this way. If you're doing a PFMEA, would you ever quote a job without knowing your estimated labor, without knowing your estimated tooling cost, without knowing your estimated CapEx? No. When you do a product design, would you ever engage in that product design without at least having an idea of the reliability expected for that product? Absolutely not. And after initiation, it goes through a phase of development. Now, development means constant iteration. And so as a DFMEA goes through product design, it eventually reaches prototype. And as a process FMEA goes through development, you eventually get to the spot where it is ready for its magical, mystical pilot run. Now, after these events, it is now in a maturity phase. Now, think of it this way. I'm going to break associations over to the human creature. I want you to think initiation as birth. I want you to think of development as adolescence, childhood, and eventually your FMEA is a full-fledged adult. Maturity means ready to go out into the world. This is mass production. This is right here on. So after maturity, it will then enter the stage of leverage. To come back to my human creature model, this is where our job is to pass the lessons learned that we've learned during our time into the next generation. The same is true with the FMEA. So the idea that the FMEA is an event was complete garbage. The FMEA is a process. And one of the things that I want you to think about, it is the iteration of the event. And the improvements that I'm going to give you during this webinar, each stage in this event has an opportunity to maximize the impact. So how do you improve the initiation of the FMEA? How do you improve the development of the FMEA? When it goes out into the field, into the world, how do you improve the maturity during its time in which it's doing its job? And lastly, once that FMEA goes end of life and the time has come for it to share its lessons learned and go quietly into the good night, how are we making the most of that opportunity? So what we're going to be sharing here, and I'm going to stop my share for just a second. What we're going to be sharing here with you is we're going to be sharing our best tips at each stage to help you. So not just once it hits the floor, because once it hits the floor, it's too late. We're going to start with initiation. So let's go ahead and get started. All right, so the initiation phase. The initiation phase begins when you are talking with the customer and ends once you've quoted and the customer said, you are our vendor. So the customer comes to you with a bushing and they say, we want you to be our vendor for this widget. A lot of your FMEA development will occur during this phase, because if you are the bushing supplier, you know that you will probably have a boring machine. You will know how many operators you need. You know you will need to have a packaging operation. And if you are a DFMEA expert, you're going to know where that bushing is going to be used. You're going to know exactly how long it has to last. And you probably, unless this is your first bushing, you're probably going to pull out some previous designs in which you benchmarked, hey, this is probably what we can provide. So a lot of the initiation work on the FMEA is done from the jump. And many, many companies I see don't take advantage of all of that work, and they try to reinvent the wheel each and every time. So the tip that I'm going to give you for this phase in the new AIAG VDA, they introduced the idea of the 5 T's, okay? The 5 T's, now don't shoot the messenger, I did not create these, are intent, timing, team, task, and tool. Now, I want to talk to you for just a moment about intent versus legalism, okay? The reason they put these 5 T's in place, they want you to begin with the end in mind. Now, for some of you, you may be familiar with an author named Stephen Covey. He wrote The 7 Habits of Highly Effective People. And one of the things in that book, begin with the end in mind. Know where you're going. So in intent, the 5 T's are not about how do we put this down on paper somehow. The intent of this statement is, do we know where we are trying to end up? And do we know when we get there? So I'm going to offer up a prioritization, right? I'm going to go ahead and I'm going to change this. This task does not have a hierarchy or a priority. When I go out into the field and I work with teams, I change up the prioritization on this and I organize them in this way. Now, this may seem like a subtle thing, but if you don't understand the power in this subtlety, you will not get to the right place. For me, the most important pinnacle of this, the most important step of this is the intent. Here's what I want you to do. In your mind, when you start your FMEA, I want you to replace intent with objective. How are we going out? What is the objective of this PFMEA or this DFMEA? This is going to help us with scope. This is going to help tell us when we got there. And the reason why it helps us, objectives are measurable. If there is nothing measurable when you talk about the intent of your PFMEA, it's going to be a bit of a hot dumpster fire. So let me give you an example from a PFMEA side. We're going to do a PFMEA, and I need it to be 15 ppm or less. I need it to be 2% scrap or less. I need it to be 45 seconds of cycle time. And I need it to run with less than, let's say, 15 minutes total labor. Let's take the decimal out. This is an intent because you are setting up a process. Now, let's fast forward. If we fast forward to launch and we start getting feedback back from the maturity stage, what happens if my PPM was 250? What happens if I run and my scrap rate jumps to 8%? Is my FMEA effective? Absolutely not. We failed. Folks, intent is the first area, and it's because from the intent, we choose the team. Okay, hear me very clearly on this. The intent comes first. Do you think when NASA plans a mission, they look at the astronauts they have and they decide on the mission? No, you decide on the mission and you pull the right individuals to accomplish that mission. That's the way it works. And the team utilizes the tools. The tools are utilized within the timing because the timing is simple, right? And the last one down here, task. Task is simply divvying up the activities. That is the lowest value of all the T's, but most people do this first. Why? Because it's easy. It's a Gantt chart. It's a timing chart. You know what's really hard? What's really difficult is figuring out when you get there, the intent. What are we trying to do? When does this thing spell success? So the first trick for your FMEA development process, the first principle that I want to make sure that you fully understand, intent comes before team. Team comes before tool. Tool comes before time. Time comes before task. And intent is objective and intent is measurable. And if your measures don't add up, your FMEA is ineffective. Rocket science, problem solved, problem staying solved. All right, so let's go back to our process here now. The second phase that we're going to look at is the development phase. Now, I'm going to stop my share for a second. I'm going to go eye to eye with you folks. When I teach, when I consult, when we do the open FAQs, one of the most important and challenging things for both D and P in aerospace, as well as automotive, is the functional analysis. When you look at the 7 steps, or as the J1739 would call it, the 6 steps, we have functional analysis. And hear me very clearly on this. Functional analysis will make or break an FMEA. I can do a poor failure analysis, but I cannot survive a poor functional analysis. For those out there on the call, if you do not understand the function, all failure is the negation of the function. That's it. So if you don't spend time on function, your failure analysis will be flawed. So what I've done in my research and my writing and my consultation here at Plexus, we go through and we do specialized functional analysis work. What I'm going to share with you here are the 2 rules that I have that nowhere else do they exist. And I'm going to share them with you today, and I'm going to show them in application. Okay. So this is true for D and it's true for P. I'm going to give you an example of both. Why? Because I like making life hard on myself. All right. Let's go ahead and clear out our screen. All right. For those who are IATF or ISO speakers, the 3 most important words when I teach systems are responsibility, authority, and the third one, the fulcrum in which they rest, is the role. Now, hear me very clearly on this. We're going to make this so simple, it'll be hard to do it wrong. You cannot give anybody a responsibility without giving them a measured equal amount of authority. Responsibility without authority has a term. We're going to use that term here. If you give somebody responsibility without authority, that is called blame. It's very simple. So notice that this all rests on the fulcrum of the role. So if you have more responsibility than you do authority, you will only end up playing the blame game. And if you give them more authority than they have responsibility, you'll be inefficient. So when it comes to design, or when it comes to FMEA, I'm going to start right here first. You have to balance the responsibility for each step in the PFMEA or the responsibility for each component in the D with the authority that it is able to carry out. I'm going to give you an example of where this goes very sideways here in a second. And the second rule that I do, every function must be unique. Okay. I was fortunate enough to work with a company that made half shafts and such not too long ago. And so when I looked at their DFMEA, every function was to transmit torque. It didn't matter what level of design, it didn't matter where. If you have a duplicate function, and there are very few exceptions, you have done a poor job. Okay. It's a lazy FMEA, both D or P. Now, I'm going to show you how this should work. Let's go ahead and take a look at these 2 rules. So if everybody's got them, Let's check them out. Now, this comes from the AIAG VDA handbook. All right. Let's go ahead and hunt. Let's check this out. Now, the reason why I wanted to do this, I'm coming up here. I'm going to stop my share for just a second. I want you to see that these are not Plexus's interpretations. These rules that Plexus did create, I'm going to apply them over to the text from the book as written. So we didn't write the book. We're going to show you how they fit. All right. So let's go ahead and do a little bit of searching here. Notice here, brush card base body transports force. Is that verb noun? Yep. Carbon brush transports electrical. Yep. Notice this function is unique to this function. Now the commutation system, and we're talking design, right? Transports electrical current. Well, that looks a lot like this, right? But notice over there, the carbon brush transports electrical current between carbon stranded wire. This one transports current between coil pairs. They are still unique. The electromagnetic converter transforms the field into angle dependent energy. And the window lifter motor converts energy to mechanical. So coming back to my first rule, did we violate any of rule 1? Is each function unique? Yeah, they didn't duplicate functions. Now let's take a look at the second rule, right? We cannot task a structural element like the brush card base body right here. Let's go ahead and highlight it. We can't task it with converting electrical energy to mechanical energy. It can't. All it can do is transports the force between the spring and the motor body. That's it. This is how this contributes. So in the DFMEA side, you're seeing the application of these concepts. Now let's talk about the PFMEA side, okay? So we're now going to go for my process folks. All right, now we're hunting, we're looking for these rules. The operator presses the button right there. The operator loads the bearing, or should say the bushing. Yeah, it's the bearing. The press machine aligns the bearing. The press machine centers the bearing. The press machine presses the bearing. Is each one of those functions unique? Yeah. Now, what does Op30 do? It presses the bearing to the axial position per max gap. That's different than these. And the entire line assembles the shaft into the pole housing. So again, folks, is every function unique? Absolutely. Did they duplicate functions? No. Now, let's take a look at this. If I am trying to, let's go ahead and do it this way, get to a max gap, can I task the operator with that? No. The operator can only push the start button. The operator can only load the part. So I have to task the right structural unit with the right function. And now let's say this is Op20. And let's say that there's an Op40 downstream. Can I task Op30 exclusively with assembling the shaft into the pole housing? No. All it can do is press the bearing to the max gap. That's it. Simple. This is one of the most complicated, convoluted things for organizations to work out. And it's so important. I'm going to back up here and I'm going to give you another shot at this. The two rules that we have developed here at Plexus that we work when we facilitate, every function must be unique. And for every single structural unit, you have to balance the responsibility you give it, the function you give it, with the authority it has to carry it out. And if you mess that up, you will never, ever, ever have a good functional analysis. All right. Now, this is going to be our second poll of the day. And the reason why we're launching a second poll, I'm going to be covering the maturity and the leverage stages. And some of these questions are going to help me figure out how far along the road you are with some of these concepts so that I know how deeply to go. All right, we're going to go ahead. These have now shown up, so I'm going to go ahead and launch them. I'm going to ask you about a concept called reverse FMEA. This is going to tell me how far I have to go with it, because reverse FMEA is about to come up in our conversation. Secondly, we're going to talk about something called Foundation and Family. I need to know where you are in the maturity for Foundation and Family. And thirdly, we're going to talk about the use of software. For those who are familiar with the Ford CSRs, you know that they are coming down the pipe here, and you know they've already kind of hit, and a lot of you are scrambling. So we're going to talk a lot about software. All right. Again, 70% is the magic number. Working it through. We are currently at 60. Keep them coming, folks. I know it's getting long in the tooth. I know you're probably tired of listening to me here this morning, but we are going to get it done. All right, and 70%, there we go. Perfect. We're going to end this and we're going to share it out. Is your organization currently performing reverse FMEA? An overwhelming majority said no or even unsure. So we are going to cover that because for many of you, this is the tool that you may utilize. The second thing that I asked you, what's your experience with the Foundation or Family? Many of you are starting development, currently developed. Some of you are still behind or unfamiliar. So we're going to talk a little bit about that. For you 27% that are unfamiliar, this is going to be an aha moment because the use of Foundation and Family will shrink your development time by 80%, easy. And most of you are still using the old spreadsheet method, 51%. Everybody else is peppered in with the other options. You are not alone. Most of you out there are still using software or still using Excel. All right, that tells me what I need to know in order to take the next step. Let's dig into maturity. Now, the first thing that I would really highly recommend you find a way to adopt. Now, as I say adopt, here's what some people heard: more work. I'm going to show you how to do this without more work, okay? Reverse FMEA is one of the tools we use here at Plexus during the maturity side. Now, the maturity side is the FMEA is out, PPAP's been approved, you're banging out 1 million parts for 5 years, it's mass production. And this only applies to PFMEA. Now, in reverse FMEA, you walk out to the line. It is a Gemba style activity. It is a go and see activity. And what you do, you work your way from the line and you're trying to validate the FMEA. Now, what do I mean by validate? In the earlier cycles, you made a theoretical prediction around the risk profile for your process. This validates it and tells you you were right, or it validates it because it tells you you are wrong. So the reverse FMEA starts on the floor. That is the really important part of this. Start the reverse FMEA on the floor. And if you see, let's say, informal channels that operators have created to get work done, you've got control mechanisms out there that they've created that you have no clue about, or you see scrap in the bin that you didn't even put on the FMEA. By the way, every piece of scrap in that bin should be aligned on the PFMEA because it's in the box because it failed a requirement. So one of the easiest ways to do reverse FMEA, empty the scrap bin. No additional work. It's something you're doing anyway, and I would highly tie it into your internal audit system so that it's not another burden. Now, things to check, because it's not fair for me to introduce a concept and go, just, do good things. Occurrence values. Validate the reality versus the performance. Pokeokes, are they still functioning? Are they still being challenged? Are they working the way that you intended when you developed it? New failure chain additions, anything that happened that hasn't been added earlier. Those last corrective actions, you got them up and on there. The scrap that's in your part bins, are they on there? And then are the controls that form the risk profile still acceptable? Let me give you a real good example of this. If you said during your initial FMEA that this unique failure chain, let's say, was a 2, I go out there and I see that there is 6 pieces in the scrap bin and you've run 30 pieces for the day, your occurrence is not a 2. Your occurrence is a 10. Scrap must be counted as part of occurrence. So the risk profile you created, garbage. So the reverse FMEA is a really good way to validate your FMEA during the maturity cycle. Now, another technique we're going to give you, when you integrate the FMEA, I've given you 2 models down here. Some of you are going to fall into that first model. Many of you on this call probably do an annual or a quarterly or some 6-month validation of your FMEA. And at that time, you look at the entirety of the business that occurred over that year, and you try to remember and cram things into the FMEA. Now, I don't know about you, but if you asked me, even in my home, to remember everything that happened with my family and my finances in a 12-month period, and then on one day, cram it all in, I'd probably forget most of it, some of the more minor events. This is because the FMEA is largely seen as being on the outside of the organizations. This is ineffective. The only effective thing during the maturity model, I want you to create a model where the FMEA is the repository of the knowledge. Now, easier said than done. How do you do it? You go to each business process, like the hiring process. And when you go to hire someone, say it's a new maintenance tech, what in your hiring process prompts you to go to the FMEA and look at the type of preventative maintenance that is going to be used as a prerequisite for the hiring decision? If you are in a high electronics environment and you have a lot of preventative maintenance relating to different boards and such, or different electronic components in a lab, you need a completely different skill set than you do if you were in a tooling environment and you need somebody that can pull a tool. Same thing with training. Same thing with sales. When sales goes to consider a new offer, how do they go to the FMEA, take a look at the scrap value, see the scrap value is 6% historically, and then figure out the right accrual to bake into the contract? You go to each one of these processes, and in the documentation for these processes, you put in a consideration for the FMEA. That is how you do it. If these processes never ask, then it will never, ever come up. Now, bit of a good news, bad news situation. The good news is everybody in this call knows what has to happen. The bad news is Only the people on this call know it has to happen. So the good news is you get to carry the flag, and that typically creates a lot more work for you. But every single process in your business should consult the FMEA. And the FMEA is the single most important repository of organizational knowledge in your organization today. In 2000s, let's say, right, the early 2000s, a buzzword struck. It was called lessons learned database. Lessons learned databases were atrociously bad, poorly coded, and generally didn't provide you much in the way of usable, searchable information. Today, the most effective repository of your organizational knowledge is your FMEA. And that's going to bring us over to the leverage. So let's go to leverage here. Now the leverage, this is where you finished up on this product over here, and you are now in the leverage stage. Now, in the AIAG VDA method, they are using the term foundation and family. Now, here at Plexus, we have complete seminars and courses on creation of foundation and family and reverse FMEA. But in reality, here is the theory, the simplistic version, the intent version of this concept. Okay. Let's go ahead and flip over to that one there. I want you to think of it like a pyramid. When you begin to get information in, the foundation has the fewest changes. Now, the example that I'm going to give you here, I'm going to give you an example for a cutting operation. If I have a cutting operation, this is quite simple. If I take a part in, and let's say that here's my raw part, and I'm going to chop it to length. There's my dead stop. There's my clamp right here. And there's my saw. This is the scrap part, and this is the length. Now, if I have one job that uses my cutting operation, and it's 10 millimeters, and I bring on a job that says I need one that is 50 millimeters, do I still have to cut to length? Yeah. What's the failure modes? Too short, too long. Simple. Foundationals are the most applicable in terms of information around process. Now, I want you to think of family as the higher level, not the highest level. Let's say that I cut, and I'm going to text this out so that we can do this. Let's say that we cut here, and I'm going to cut metal, and I'm going to cut plastic. Now, for anybody that has ever cut plastic, if you overheat plastic, what happens when the plastic cools? It may shrink, right? So if I am cutting plastic and I run my saw too hot, would there be a unique failure cause on that plastic that creates the mode of too short? Sure. So I might divide between metal and plastic. If I have a cutting operation that is manual and I have a cutting operation that is auto, could I divide by the type of technology? Sure, because there are things in automatic cutting that aren't in manual. And lastly, each part number needs to be at least evaluated for anything that is unique. And I will tell you, if you do your job correctly, 80 through 90% of any new job that you take will be handled by the foundation or the family level. Now, there are those weird times where the product or the process is so revolutionary that you may have to start from scratch. But for the most part, your foundation or your family should take care of it. And for my design folks, if you are designing clips and you are designing, let's say you've got a mechanical lock on a clip and then you've got a compression lock on a clip, chances are your foundation for a clip, right? It always has to hold to a certain pressure. It probably has to hold to a certain diameter of thing. When it comes to family, there are ways that a compression clip versus a mechanical clip fail in their own special way. And the reason why this is a leverage move, because as you get more information in, you should be considering, as those PPMs come in, does this need to affect the foundation? Is this only applicable to the family? Or is this a part number specific issue? Because anything you put in here is going to get fed right back into here for initiation. If you do your job right, your FMEA should provide you the most realistic risk profile in terms of your new product based on your historical product. All right. So one last slide here. If you have questions, get them in. Chris, are you with us?
Yes.
All right, folks, what's about to happen here? You're going to get a post-event survey following the webinar. I'd appreciate it to fill this out. Keeps our content valid, lets us know what you like, what you didn't like, that sort of thing. But for right now, the part that is interesting to me, questions. Chris, why don't you go ahead and let's fire away, my friend.
Yeah, thanks, Jeremy. Thanks for.
Oh, your mic is weird, bud.
Oh, 1 second. All right. Is that better?
Kind of.
Thanks everyone for attending. I'd like to thank you, Jeremy, for leading us today. And while anybody has questions to submit, thank you for attending. If you're looking for more information on FMEA tools, you can check out our 2-hour Reverse FMEA seminar with AIG on our website. We also have a number of 90-minute video e-learnings, Foundation, Family, Cost of Quality, or FMEA development. In addition to open enrollment, design, transitioning workshops, understanding and implementing control plans for small teams, serving your global supply base.
Chris, you're having audio issues. So on this one, I've got the questions up. I'll go ahead and read them if that's okay. All right. Problem solved, problem staying solved. Always have contingency. All right, let's go ahead and start with the Q&A here, folks. Is it okay to have a target for RPN for recommended actions? Here's the thing. Even in 3rd edition FMEA, and especially in 4th edition, they mentioned use of an RPN threshold being target is not a recommended action. Okay, so here's what I want to make sure you understand. With this, if you have RPN, you can do whatever you want to do and you get whatever results you're going to get. You can't see it from my house. In my world, you do not put a threshold on RPN ever, 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 ever. And the writers of the 3rd and especially the 4th edition said that. So if you're still doing it and you gotten away with it this far and it's working for you, remember, it's all about whether or not it's working. All right. Good deal. All right, let's take a look at this one. In PFMEA, function of an e-motor assembly line should be assemble e-motor. Absolutely. That's why the e-motor assembly line exists. What does the line do? They assemble the electrical motor. Yeah, simple. All right, next one from Steve. When you state every function must be unique, the higher level processes such as op30 without duplicating the next lower level process. All right, so let's go back to the example we had here. And I'm just going to go ahead. I'm going to step back just a bit, folks, in our example. I'm not going to create a new one. I'm going to keep working with what we're doing. So let's do this. I'm going to share out my slideshow real quick. All right, 1 second. Not quite there yet. Awesome. All right, coming down. So you guys can see my screen now. So let's say that we assemble the shaft into the pole housing, right? So I'm going to make up a couple stations. I'm going to go to op 20. Okay. Now realize I am making these up as I go. Op 20, we're going to say clamp shaft into position. This is the operation 20. Now let's add a little context to it. How come y'all can't tell me that I didn't? Into position. There we go. I can spell today. All right. So let's say op 20 goes to clamp the shaft into position. Now what's going to happen, folks? Let's add some context here. Here is a shaft. Here is the housing right here. We're going to press the shaft into the housing, right? So op 20 is going to clamp the shaft into position. Now, op 30 is going to press this bushing onto the shaft. So op 20 clamps the shaft into position. Op 30 presses the centered bearing into the shaft to the correct axial position. Now, let's go ahead and add an op 40. Op 40. Now, let's say after this part, we have an inspection step. The inspection step, their function would be inspect gap on shaft. That is its function. Now, let's add one more. Let's go to op 50 now. And in op 50, op 50 is going to assemble shaft or press shaft to housing. Notice how each of these are unique. Now let's check out the uniqueness. In op 20, we clamp the shaft into position. Op 30, we press the bearing into the shaft. Op 40, we inspect the shaft gap position. Op 50, we take this entire shaft assembly and we press it into the housing. All of these steps come together to assemble the shaft into the pole housing assembly. It takes all of these steps in order to do it well. That's how this works. And I did not replicate any sort of function. All right, that's a very good question there. All right, we're gonna stop the share here. All right, let's do this one. I have a question. Should all lessons learned be cascaded throughout the foundational FMEA when there are different plants producing similar products? Which FMEA should we consider the reference foundation FMEA? It depends on your organization structure. My thought is if one plant had the error and you want the other plants to put in a similar poke yoke, it's up to you which one you consider to be foundational. I do have foundationals that occur at every plant. I do have some multinational companies that are creating a foundational at the corporate level for use at the plant. The short answer is it depends on your structure. There is no one size fits all. What I would do, I would map out, here's a plan, and now test it. If I get feedback here and I run it through my plan, does it work or doesn't it work? If it doesn't work, change the plan. That's the way that I would definitely do that. All right. Next one. Could you please clarify frequency of conducting PFMEA reviews? Here's my thought. That is always a customer requirement, customer specific. There is never, ever, ever a requirement in the blue books or the blue and red book now for the review frequency. that is always a customer specific that you signed up to. So if you have one to do it annually, make it annually. If you have one to do it quarterly, do it quarterly. And this is a good one that I wanted to cover with you folks real quick. With this, there are no rules in the FMEA manuals. The rules come from your organizations or the CSRs. All right, good question. All right, explain the difference between RPN and action priority. Okay, now this question is above. Could you explain the difference between RPN and action priority? Why in the 4th edition they recommend AP? Okay, in 4th edition FMEA, they used a term called RPN, a risk priority number. This was a multiplication step that was designed to quantify risk. The reason they went away from that, organizations became super good at the math instead of the intent. In the new AIAG VDA, they use something called action priority. And what I would do there, AP puts severity first, and it gives you 3 options: high, medium, and low. So at a high level, which is what we can do with this webinar with 4 minutes remaining, RPN was a numerical value. It was the product of severity, occurrence, detection. AP takes severity. It still has the same severity, occurrence, detection values, but it now gives you a high, medium, or low. And what they're trying to do, they're trying to get you to drive actions that actually provide improvement. All right, who's responsible for the PFMEA in the series phase? It depends on your organization. You can give responsibility to the janitor if they can get the job done. I see in a lot of organizations, engineering takes responsibility, but then it gets thrown over the wall to quality. Here's the thing. Do not get held up on organizational titles and who should if there is a proven track record that they cannot. I will give the FMEA to whoever has the correct level of authority, depending on my organizational structure. So the short answer is, there is no rule. There is effective and ineffective. And if it's ineffective, stop giving them responsibility. All right. Any particular FMEA software you would recommend? All right. I got 2 questions left and then we'll end this thing. I got 2 minutes and 2 questions after this. Software. I was one of the technical resources for the AIAG Core Tools software package. It is very close to Excel with all of the bells and whistles that you need to do Foundation and Family. So the one I am intimately familiar with that Plexus had a hand in helping to develop is the AIAG Core Tools software. That being said, if you are a large multinational organization, I have clients that are using QSYS, they're using Plato, whatever you want to call it. There are a lot of software packages. It depends on your organizational size and the complexity of that organization. For most of you using Excel sheets, your world would change substantially with the AIAG CTS software. I'll just tell you that. All right. Now, second question, an example of PFMEA format for one function. I do not have that loaded up. So JA, that one I can't give you, man, because I don't have that one loaded up. I apologize. All right. All right. And lastly, what would a replicated process in the bearing assembly example look like? Can we see what could go wrong? Oh, okay. Now, let me show you this. This is the last thing I'm going to answer here. So we're good. I got through all the questions. I got 1 minute to go. I'm surgical with this. All right. Here's the thing that you may never figure out. And I'm going to share this with you right now. Max gap per print is the thing on the print. That is the product characteristic. Remember that failure is the negation of function. So if the operator is supposed to load the sintered bearing, what could go wrong? operator doesn't load centered bearing. If the machine is supposed to align the centered bearing, machine improperly aligns centered bearing. In doing the functional analysis, you get the failure analysis. So to answer your questions, JV, what can we see what could go wrong? It is all just in the negation of function. Once you have the functional analysis, everything else is downhill from there. Failure is always the negation of function. All right, Chris, did you get your audio worked out so you can say goodbye to us here?
Perhaps. Thank you,
Yes.
Jamie. All right. Thanks, folks, for joining us today. Jeremy, thanks a lot. If you are looking for more information, please feel free to visit us at plexusintl.com. Jeremy's online too on the socials. Hit him up there. Otherwise, give us a call. Thanks again, Jeremy. Thanks you all for attending.
All right. Have a good one.